its ID. And it's quite a simple one really. We just use the method find by ID to do that. So here in this student client on line 21, we are creating a student, Elisa, and we are persisting it in the next line using the save method, which will issue an insert statement and persist our student into the student table. And then on line 24 here, we are using the find by ID method and passing into it the ID of the student that we want to look for. So we are passing the value 1 here, as we know that we do have the student with ID 1 available in database. So once the line 24 gets executed, the find by ID method here will issue a select statement and give us an optional in return, which is of type student. So the optional here will either contain the students with ID 1 or it will be empty. In case you're not aware of it, an optional is a container object, which either contains a value or it's empty. So in our case as well, as the optional here is of type student, it will either contain a student or it will be empty. And to get the value that's inside it, we are calling its get method here in the next line. So if the optional here does have a student in it, then with the get method call, it will return that student and will be assigned to the student by ID variable here. Otherwise, it will throw an exception. And then in the next line, we are printing it on console. So once the line 26 gets executed, we will have the student with ID 1 printed for us on console. And in case you're curious, the find by ID method here relies on the find method of an entity manager. But we don't really need to know about that, as the find by ID method here is issuing just a select statement, which is what we expect it to do. I mentioned it just in case you were wondering about that. And we'll be getting the same results in our Eclipse IDE as well. So what I'm going to do here, and I'm going to place a breakpoint here on line 22, and then run our application in debug mode. So what we are doing here in our student line is that we are persisting the student first, and then we're going to find it by its ID. Okay, so let's execute the line 22, which will create our students in memory, and then we're going to persist it into our student table. So at this point, we should be having our student inserted into the student table. Yeah, we could see here that it's been inserted. And then we are using the find by ID method to get that student loaded into your application, which will give us an optional of type student. So let's execute the line 26. And then we are using the get method of the optional to get what's there inside it. And then finally, we are printing our student. Yeah, we could see here on the console that we got our student that we had persisted on line 23 loaded back into our application. So that's about finding an entity by its ID. In this session, we'll be deleting an instance of our student entity. So here on line 21, we are creating a student, Alisa, and then we are persisting it in the next line using the save method, which will issue an insert statement and then persist it into the student table. And we could see here that the object returned by the save method, we have assigned it to the return student variable, which we'll be deleting next. So on line 24 here, we are using the delete method to delete a return student. And once once it gets executed, it will issue a select statement and then the delete statement, which will delete a student from the student table. And that's all it takes to delete an instance of an entity. Now, if you're wondering that why is this select statement is issued when the delete method is called, then it's because before deleting a student, Hibernate first checks that whether we even have that student in the database or not. And the way it does that is that under the hood, it calls the find method of an entity manager to find a student whose ID is 1. And then it checks whether the result of that find method call is null or not. And only if it is not null, which means that we do have a student with ID 1 in a student table, only then it goes ahead to delete that student. So basically, the find method call here was the reason behind why we had this select statement issued. Now, as an optional part of this session, let me just mention here that the entity manager, which behind the scene is doing the work of deleting a student, does not delete the object referenced by the return student variable here. It deletes a different object instead. And in case you're interested to know more about that, then let's see how exactly the delete method is doing it. So we know that when the line 22 completes its execution after persisting the student Alyssa, we will have a return student in the detached state. We saw that in one of our previous sessions, so we're not going to repeat that here. So we have a return student in the detached state, which we are deleting on line 24. So on line 24, when the delete method is called, it first begins a transaction with an entity manager for it. And then before the entity manager attempts to delete a return student, Hibernate first checks that whether the student that we are trying to delete does it even exist in our database or not. And it does that check through the find method call that we talked about a few minutes ago. So once the find method is called, it issues a select statement. And if that student is found existing in the student table, like we have it in our case, then it will be loaded into the persistence context. And it will be in the persistent state and managed by the entity manager here. So that's the first part of the delete method. That is, to check first that the object you're trying to delete does actually exist in the database. And it does that using the find method. And then in the second part of it, it uses the entity manager's remove method to delete a student. But before it calls the remove method, it checks first that whether the return student that it's supposed to delete is even being managed by the entity manager here. And we could see here that it's in the detached state and not being managed by the entity manager. And because it's not being managed by the entity manager here, it cannot be deleted because attempting to do so will throw an exception. For an entity manager to be able to delete an object, that object should be in the persistent state and being managed by it. If an entity manager tries to delete an object that's in the detached state, it throws an exception. So to resolve that issue, what it does next is that it uses the entity manager's merge method and pass into it a detached return student. And what it does is that it gives the entity manager here a persistent student that it then could use to delete a return student from the student table. So the way the merge method works here is that it first checks whether the entity manager here is already managing a student whose ID is same as the ID of the return student. And we do actually have a student like that in our persistence context being managed by the entity manager here. So it doesn't need to issue another select statement to load one from the database, as the one already existing here will be used as the result of the merge method call. So it then just completes the merge method call by copying the data of our detached student onto the persistent student. And with that, it now has a persistent student with the same ID and data as a detached return student. So it could now call the entity manager's remove method without worrying about an exception being thrown. So it does that next and calls the entity manager's remove method to delete our students by issuing a delete statement. And once that happens and the transaction commits, our student gets deleted from the student table. So that's basically how it works. And then when the transaction commit completes and the entity manager gets closed, the persistent student here moves from the persistent state to the removed state and becomes eligible for garbage collection. So that's how the delete method works. It first issues the select statement and then the delete statement. And as I mentioned earlier, the delete method to delete a return student did not move it from the detached state to the persistent state. It created a new object for that instead through a merge method call. So it did not delete the object referenced by the return student here. It deleted a different object instead. So at the end of the execution of line 24 here, you'd have your return student still in the detached state, while this other object here will be in the removed state. So that's really it about how the delete method deletes an instance of an entity. Now, there is another method that you could use to delete an entity. If you want to delete an entity by its ID, you could simply use the delete by ID method, passing into it the ID of the entity that you want deleted from the database. So this time on line 24 here, we are deleting a student with ID 1 using the delete by ID method. And once it gets executed, we will have our student with ID 1 deleted from the student table. Now, what if you want to figure out whether an entity exists in the database or not? Well, if you know the ID of that entity, you could simply use the method exists by ID for that, like we are doing here on line 24. We are using the exist by ID method to figure out whether the student with ID 1 exists in the student table or not. If it is found existing, then the boolean value true is returned, but if it's not found, then the false in return. And the way it figures out whether an entity exists in the database or not is by issuing a select statement and counting the number of rows returned by it. If the number of rows returned by it is 1, then a true is returned, otherwise a false is returned. So when the method exists by ID here on line 24 gets executed, this select statement is issued, counting the number of rows returned by it, where the ID of the student is 1. And we will get true as the result here, as we did persist a student on line 22, which got inserted to the student table. So exist by ID was another method that I wanted to talk about in this session, besides the other two delete methods. Alright, now let's try the same examples in our Eclipse IDE. So what we are doing here in our student client is that we are first persisting a student and then we are deleting it. And then we are checking that whether the student with ID 1 exists in a database. And depending on the result we get, we again try to delete it, but this time we try to delete it using the delete by ID method. So let's execute this student client here in debug mode. So I've placed a breakpoint here on line 20, and then I'm going to run our application in debug mode. Okay, so the point of execution is on line 20 at the moment. So let's execute the line 20. And then the 21, which is going to save a student into a student table. So at this point, if we go to your test DB, and see what's there inside our student table, we should find our student Alyssa inserted into it, as we could see here. And then we are going to delete that student Alyssa using the delete method on line 24. So let's execute to line 24 now. And we could see here on the console that the delete method first issued the select statement here and then the delete statement. And at this point, if we again check our student table, let's first make a refresh here and then again try to see what's there inside our student table. Yeah, we could see here our student Alyssa has been deleted. Now, on line 27 here, we are going to check that whether the student whose ID is 1 exists in the database or not. And we are using the exist by ID method for that. So let's execute the line 27. Yeah, we had a select statement issued. And at this point, the value of this isFound variable here should be false because we do not have any student in the student table. And because of which, this delete by ID method here will not get executed, which actually is going to avoid an exception being thrown. Had we attempted to execute this delete by ID method without having this if block here, it would have thrown an exception. So we could use this exist by ID method to check first that whether the student that we are trying to delete actually exists in the database or not. So that's about deleting an entity. So far in this course, we've been using a student client as an application runner to test our student repository. Like we ran this student client here in the last session to see how the deletion works using our student repository. And it's fine sometimes to see your code working properly using a client like this. But you might also prefer to write your test cases for that. So in this session, we're going to see a simple test case in which we'll be testing the CRUD functionality of a student object using a student repository. So I have imported our Maven project here. And before we go ahead and run a test class, let me just delete this student client here. Or if you don't want to delete it, at least make sure that you comment out the component annotation here. Otherwise, you might end up getting some conflicting results when you run your test cases. I'm simply going to delete it as we do not need it for this session. So here is our main application test class, which is our Spring Boot test class that we have annotated with the Spring Boot test annotation. What this Spring Boot test annotation does here is that it loads the full application context when you run this test class here. Just like we get the Spring container started when we run our Spring Boot application. So using this Spring Boot test annotation here, you could test all the different layers of your application. But in this session, we'll be testing just the persistence layer. So we are doing here the create, update, read, and delete operations on a student object using our student repository. So after annotating this test class here with the Spring Boot test annotation, we are auto-wiring our student repository using the auto-wired annotation. And then we are annotating our test case here with the test annotation. And then inside this test method, we are making some assertions, as we can see here. So let's run this test case here in debug mode. Everything inside the test method here, we have seen all that already in the previous sessions. But just for completeness, let's quickly go through it again and see the green bar after it passes the test and all the assertions that we made in it. So I'm going to place a breakpoint here on line 26 and then run this test class here in debug mode. Okay, so the point of execution at the moment is on line 26. So on line 26, we are creating a student's object, and then we are persisting it using our student repository. So once the line 27 gets executed, we should have our student persisted in the database. And the student that we are getting in return after calling the save method is being assigned in the return student variable here. So if we check the ID of the return student variable here, like we are doing it on 28, we should get a not null here. So let's execute the line 28. And then we are going to update our student. So on line 31, using the return student variable, we are updating our student by changing the spelling of the name Alyssa with a double S in it. So let's execute the line 31. And then on line 32, we are again calling the same method to make those changes made to the return student persisted to the database. And this time, we are assigning the return student to the updated student variable here. And then we are asserting here that the spelling of our student has been changed. And then we are reading a student by its ID. And then on the next line, we are asserting that the ID of the student that we found is 1, as that was the student that we looked for on line 36. And then we are deleting our found student on line 40. And then we are asserting on line 41 that we no longer have the student whose ID is 1, that it's been deleted from the database. And then if we just go ahead and resume the execution of our test class here, we should see a green bar. Yeah, we could see here that the test that we have here, the test CRUD method, passed successfully, which indicates that all the assertions that we'd made in it were correct. So besides writing a client class and running it as an application runner to test your repositories, you could always write a test case like this. In this session, we'll talk about Spring Data Comments. So what is Spring Data Comments? Well, the Spring Data JPA that we've been using so far in our applications is actually built on top of the functionalities provided by the Spring Data Commons. And as I mentioned in one of the previous sessions, that when we use Spring Data JPA, then the JPA repository is not the only repository that we get. We get a few other repositories as well that we could work with. And as we could see here, that the JPA repository that we have used so far in our applications, which our student repository also extended from, itself extends from the paging and sorting repository here, which actually is a part of the Spring Data Commons. So with Spring Data JPA, besides the JPA repository, we get these 3 repositories as well from the Spring Data Commons that we could work with. And out of the 3 repositories here, the first one, the repository interface at the top of the hierarchy here, is just a marker repository and doesn't have any methods declared in it. It's mainly used to capture the entity type that we want to create a repository for and the type of the ID attribute in that entity. And it also helps the string container to discover any concrete repository interface during the class path scanning. So this was how the string container got to know about our student repository interface. And then this CRUD repository here, as the name suggests, provides the CRUD methods. In fact, all the methods that we have used so far, the save methods, find by ID, delete, and other methods, they all have been declared in this CRUD repository. So our student repository, which we made to extend from the JPA repository, if we had rather made it extend the CRUD repository, Even then, everything would have worked just fine for us. So if your repository is doing just the CRUD related work, then you could choose to make it extend just from the CRUD repository. Just because you're using the Spring Data JPA doesn't mean that JPA repository is the only repository that you could work with. You could choose your concrete repository to extend from the repository that's more appropriate for you. You could even make your own custom repositories to extend from in case you need to. But we don't want to complicate things here at the moment. We'll talk about that later. And then we have this paging and sorting repository, which has methods that are used to sort and paginate entities that are retrieved from the database. And then finally, we have our JPA repository, which besides extending from the paging and sorting repository, provides some extra JPA specific methods as well. For example, using the explicit flush method call, you could flush all the pending updates in your persistence context to your database. And if you want to batch delete your entities, it has the support for that as well. It's quite easy to point out any batch related methods, as they all end with an in batch suffix, as we could see here in the delete all in batch method. We look at the examples of some of the commonly used methods from these repositories later in the course. At the moment, we just want to talk about the Spring Data Commons. So that's about the repositories we get when we use Spring Data JPA in our application. Now, what if we are not using a relational database? What if we are working with a document database instead, MongoDB for example? Would we still be able to create repositories just like we created the student repository using Spring Data JPA? Well, the answer is yes. Just like the Spring Data JPA, which provides JPA persistence against a relational database, we have another project called Spring Data MongoDB, which provides persistence to a Mongo document database. And just like the Spring Data JPA, the Spring Data MongoDB is also built on top of the Spring Data Commons. And again, just like we get the JPA repository with Spring Data JPA, we get the Mongo repository with Spring Data MongoDB, which again, just like the JPA repository, also extends from the paging and sorting repository from the Spring Data Commons, as we could see here. The thing is that all the three projects here, the Spring Data Commons, the Spring Data JPA, and the Spring Data MongoDB, they all are the sub-projects of a larger umbrella project called Spring Data, whose main purpose is to provide a consistent data access programming model to all the relational and non-relational data stores while still retaining their special traits. The Spring Data JPA and the Spring Data MongoDB are the data store specific projects here, but they both share the functionalities provided in the Spring Data Commons. And that's how the Spring Data project tries to provide that consistent data access programming model to different type of data stores. Both the projects here, the Spring Data JPA and the Spring Data MongoDB, they both are sharing the repositories abstracted away in the Spring Data Commons. So once you get familiar with the Spring Data Commons and the methods declared in its repositories, whether you're working with Spring Data JPA or Spring Data MongoDB, you will not find them very different while working with them. And moving from one type of data store to another won't be too difficult either. So basically, the Spring Data Commons here provides an infrastructure of technology-neutral repositories that is shared by all the other data store-specific Spring Data projects. And we've talked about just two of those projects here. If we go to the Spring.io's Spring Data Projects page, you will find that there are many such projects for different type of data stores, as we could see here. And they all share the Spring Data Commons project. With this Spring Data JDBC, you get the JDBC-based repositories for your relational database. And with Spring Data Redis, you get the support for your Redis key value database. All of these projects here are the sub-projects under the Spring Data project. You could take your time and read more about them if you're interested. We, however, will mainly be talking about Spring Data JPA in this course. And before I forget to mention it, Spring Data JPA, besides being built on top of the Spring Data Commons, of course is built using a JPA provider. And Spring Data JPA by default uses Hibernate for that. So that's about the basic overview of Spring Data Commons that I wanted to talk about in this session. Let's have a quiz. In this question 1 here, it's asking us that how could we create a repository for our student entity that has two methods from the CRED repository and one method from the JP repository. The first two methods, the save and the find by ID methods here, are from the CRED repository, and the find all method is from the JP repository. We want to have a repository with just three methods in it, and we are calling it my custom repository. So how do we create it? We have to choose the correct option from the 5 options given below. Take your time, think about it, and see if you could answer it, and I'll get back to you in a moment. Well, the answer is that the option C is the correct option. Making our My Custom Repository extends the repository interface will do the job for us. The thing is that once we have a repository that extends from the Spring Data's repository interface, we could add into that repository the methods we need from the CRED repository, paging and sorting repository, and the JP repository. So to be able to have methods from the 3 repositories, we just have to make a repository extend the repository interface. And once we do that, Spring Data at runtime will dynamically create a proxy providing implementation for all those methods. So the 3 methods here in our My Custom Repository, once we make it extend the repository interface, Spring Data will dynamically create a proxy at runtime to provide their implementation. And that's how we create a custom repository with just 3 methods in it. That's how we would create our My Custom Repository, having 2 methods from the CRED repository and 1 method from the JP repository. So again, to make a custom repository, we first make our custom repository extend the repository interface and then add methods into it from the methods declared in the CRED repository, paging and sorting repository, and the JP repository. So that's how the option C is the correct answer. Now, you might ask that why would we need such a custom repository when we could just make a repository extend the JP repository, which would give us all the methods not only from the JP repository, but also from the paging and sorting repository and the CRED repository. Why would we want to create a custom repository with just a few of the methods when we could have all the methods from the JP repository, paging and sorting repository, and the CRED repository? Why would we do that? Well, it's a good question. And one of the answers to that question is that maybe you do not want a repository exposing all of those methods from the 3 repositories. Maybe you just want to define a custom repository that's easier to use, more efficient, and also more appropriate for your needs. Something that follows the internal guidelines of your team as well. Or maybe you do not want to expose any delete methods in your custom repository and want to have just the save and finder methods in it. Or it could be for any other reason. The thing is that if you have a requirement to create a custom repository in your application, then you know now how to create one for yourself. So that's about the custom repository. Now quickly, let's get on to your Eclipse IDE and test our custom repository.
So here is our student entity with an ID, name, and enrollment ID data attribute. And here is our custom repository that we have created for a student entity. Our My Custom repository here is extending the repository interface from the Spring Data package. It has this save methods from the CRED repository and also this find by ID method, which is also from the CRED repository. And this find all method here is from the JPA repository. And here is our Spring Boot test class testing our My Custom repository. So first we are testing the save method. So we are first creating on line 24 a student, Alyssa, and then using the save methods of our custom repository, we are persisting that student. And then on line 26, we are asserting that the ID of the return student is not null. And then we are testing the find by ID method. We are finding our student whose ID is 1. And then we are asserting that the found student has the ID of 1. And then we are testing our find all methods. We are finding all the students that we have in our student table. And we are asserting on line 34 here that we'd be getting just 1 student in return. So the size of the return students list would be 1. Now let's go ahead and run it and see whether a test here passes successfully or not. It should be passing successfully. Yeah, we could see here the green bar, meaning that a test here passed successfully. So that's about the custom repository.